video, we are talking about function operations and compositions. So before we begin, there's a few different rules that we need to go through. These are the properties or how to handle function operations. So the first one we have is if we have addition, then that means we have either h of x equal to f of x plus g of x, or we have h of x equals to f plus g of x. Now, what does that mean? Well, that means if you see, let's get rid of a highlighter, if you see them asking for f plus g, what you're going to do is you're going to take the function of f and the function of g of x, and you're just going to add them together. So this is the notation you're going to see, and what you do is you take both of the equations and then add them together. For example, let's do the examples later. Actually, I lied. Let's go ahead and do that example. For an example, if you have f of x equal to 5x, and you have g of x equal to x plus 2, and they are going to ask you for h of x, which is f plus g of x. So if you see that notation, all you got to do is you take your f, which is your 5x, and you add that to your g, which is your x plus 2. Now, I highly encourage you to put parentheses around these until you know for a fact there's nothing to distribute. This will occur especially if you are subtracting. Since we're just adding, we have 5x plus x plus 2, which means we have 6x plus 2 equal to our h of x. So this is your answer. The next one we have is subtraction, so let's do that. So again, we're talking about what we have and what it means and what we see. So if we are subtracting the two equations, your f of x minus your g of x, then the notation you're going to see is your h of x equal to f minus g, and then you have your x. So how will that look like for the equation? I'm going to highlight the two original ones, this one. These are the ones that I'm going to be using throughout for examples. So for the example, we are going to take f minus g of x. So what does that mean? It takes your f of x equation and minus your g of x equation. So here's an example where that parenthesis comes really, really important. Because you have this minus, you have to distribute that onto x and onto your 2. So that means you have 5x minus 2, which means that your h of x equals to 4x minus 2. Moving on to multiplication. We again have h of x equals to, you take the f of x equation times your g of x equation. So when they're asking you to do that, what you're going to see is h of x equals to f times, now it's very important that this is a multiplication, not an open circle. We'll talk about that here perhaps in the next video. And so what that means is you take your f of x equation, so in this case, let's write that out, f times g of x, take your f of x equation, which is 5x, and you're going to multiply that by your g equation, which is your x plus 2. Now, I am going to rewrite this because we have a monomial times a binomial, so that means we got to distribute. That means we have 5x times x plus 2. We're going to distribute that 5x. 5x squared plus 10x is your answer, your product. And lastly, we have division. Now, division sometimes can lead into like simplifying. So if we get to that, I'll discuss that a little bit later. It does tend to go into a different unit, but we'll try to keep it to like some of the simpler equations or some of the simpler examples for dividing. So for dividing, we have h of x. So when you divide your top equation by your bottom equation, that is when you see h of x with f on top, g on the bottom of x. Now again, that goes into rational expressions, rational equations, so that sometimes can lead to something a little bit more challenging. We're going to keep it on the basicer side. So for example, if we have f of g of x, we would then get your f equation, which is 5x, and your g equation, which is x plus 2. And that is it for right now. I am going to tell you that this does not simplify further. Jumping into some of our examples. Let's say, for example, we have f of x equal to 2x squared minus 5x minus 3, and we have g of x equal to x squared minus 4x plus 3. And what they're going to ask us is they're going to ask us to do all of these operations. So for number 1, they're going to ask us f plus g of x. And then right away, I'm going to do number 2, which is asking us for f minus g of x. So the first thing we need to notice is that f plus g are talking about the functions, right? The x that's out on the outside, that just means that that's the letter they're using. So if, for example, the equation did not have a letter x, but instead had a letter a, then you would see an a in this spot. The operation that you're doing is the one that has between the f and the g. So we have f, which is 2x squared minus 5x minus 3. Make sure you have that in parentheses. Plus g, which is x squared minus 4x plus 3. And we're going to add that together. That is in your unit 1. And also it's a prior knowledge skill from integrated math 2. So we have 2x squared minus 5x minus 3 plus x squared minus 4x minus, just kidding, plus 3. Go ahead and combine like terms. I have 3x squared minus 5 minus 1, minus 5 minus 4. That's a minus 9. And then we have 3 and 3, which is nothing. So this is our answer. Now for the second example, it's asking us to subtract. So we write out f, we write out g. F is 2x squared minus 5x minus 3. Again, parentheses are really important. We're going to subtract that from x squared minus 4x plus 3. Because we need our bubbles, because we have the distribution occurring, we got to do the arrows, what I call them. So we have 2x squared minus 5x minus 3 minus x squared plus 4x minus 3. So that changes everything. So let's go ahead and simplify that. We have 2x minus x, so we have 1x here. We have a minus 5 plus 4, we got a minus x. Negative 3 and a negative 3 gives us a negative 6, and here's our answer. Moving on to example number 3. Example number 3 is going to ask us to do g of x minus f of x. Now on this example, they are using a little bit of a different notation, and that's okay. So if we go back up here to our first rules, and it says for subtracting, you might see this notation, or you might see this original notation. Either way, what it's asking you is you're subtracting. So in this case, it's asking you to take your g of x equation, your x squared minus 4x plus 3, and then it's asking you to subtract that f of x equation, which was 2x squared minus 5x minus 3. So then let's go ahead and do that. Don't forget you do need to distribute that negative. That's the whole point of it. So we have a minus 2x squared plus 5x plus 3. So now we have a negative x squared, a positive x, and a positive 6. Question number 4 is asking us to do g times f of x. And so what we do here is we're going to take our g, I'm going to separate this out. We're going to take our g, which is x squared minus 4x plus 3, and we're going to multiply by 2x squared minus 5x minus 3. Now, because we have two trinomials, I am going to encourage you to use the box method. If you prefer to FOIL or distribute, that's okay. That's your choice. But for me, I prefer box method. Helps me out. So I'm going to do x squared, negative 4x, and 3. And here we're going to do 2x squared minus 5x minus 3. So here, try to grab a different color. Turns out I like the black pens. So we got 2x to the 4th power. We then have negative 8x cubed and 6x squared. Here we got negative 5x cubed, positive 20x squared, negative 15x, and here we got negative 3x squared. What is this? Positive 12x and a negative 9. Going inside, we have to simplify the ones that have the same exponent. So I'm just going to do squiggly circles here. Oh, and I almost forgot we do have one more pairing. So we have 2x to the 4th, 8 and 5, so 8, 9, 10, 11, 12, 13. So we got negative 13x cubed. Here we have 6 minus 3, which is 3, plus 20, which is 23, x squared. And then we got 15 and 12, 12, 13, 14, 15. So we got negative 3x. And then a negative 9 left over. So here's your answer for that one. For our last example, we're going to be doing a division. And I'm going to kind of give you a preview of our next unit. But you are for sure responsible to know how to divide these. We might just give you something a little bit on the, like I said, on the basicer side. So for division, we have f of x divided by g of x. Or you might see f divided by g of x. Either way, it means the same thing. So we have our f of x, which is 2x squared minus 5x minus 3, and then divided by x squared minus 4x plus 3. Now, the whole point of dividing these trinomials is to see if things can simplify. So let's go ahead and I'm going to do the denominator first. We're going to factor. So we have these two bubbles, and we're going to say we have a 3, we have a 1, both of them are going to be negative, so we have an x minus 3, x minus 1 as our factors. For this one here, I'm going to do a thinking bubble and do a really quick rainbow method. So we got x squared minus 5x minus 6, so that means we have a negative 6 plus 1 as our factors. Divide by the original 2, divide by original 2. Yes, I'm going quick for a reason. X minus 3, as we learned this last time, 2x plus 1. So we got on top x minus 3, 2x plus 1. So then all we're going to do is take a look at the bubbles. Now, factoring just means we're undoing multiplication. So if we were to multiply the top two binomials, we would get this trinomial. If we were to multiply the two bottom binomials, this would be your trinomial. So now that we have undone that multiplication, we can then simplify by crossing it out, okay? Don't actually cross things out. I mean, do actually cross things out. But what that means is we're going to divide x minus 3 bubble divided by x minus 3 bubble. That means that it divides into a 1. Like 2 divided by 2 is 1. 3 divided by 3 is 1. 4 divided by 4 is 1. As long as the bubbles are matching, as long as the factors are matching, you can simplify and cross them out. So x minus 3 divided by x minus 3 is 1. And it's just a 1 times, right? So we got 1 times 2x plus 1. And we got 1 times x minus 1. So these are your quotients, right? This is your answer after you have divided things out. Now, I do want to point out that there is more to this. We are not talking about, excluded values. There are some excluded values for here. I'm just asking you to divide. We're going to talk about all of that when we get to that unit. That is it for our simplifying for the composition of functions. That will be in a different video. Thank you so much. Bye.